Welcome back, it's Rob again. I'm going to go through a really key concept here in finance now, and that's the notion of the annual effective rate. We've been working with something called the nominal rate up until now, the J or the JM, and so that might be like a J12 or a J2 or a J4, J365, that sort of thing. That's the annual rate, but then compounded that number of times per year. The interesting thing about that is because of the compounding effect, the nominal rate doesn't really tell you what you're going to get after a year. So if I say, oh, you get 5% compounded monthly, you're actually going to get more than 5% interest because of that effective compounding, aren't you? And that's a pretty important thing, and that's the whole benefit of compounding. So then the question you may have already been wondering about at times is, what rate am I really getting, or how much will I get on my money once the compounding has been factored in? That's called the annual effective rate. It's a very important concept, and you see a lot of times when you look at advertising for loans or that sort of thing, maybe in the newspaper, a car dealer's got a loan, or you get a credit card, application package in the mail, and they're trying to get you to sign up, that sort of thing. Somewhere in the fine print, they will tell you the annual effective rate, which may look a little bit bigger than the rate that's quoted up top, because that one might be compounded, several times a year. So in order to make things fair for people and help them understand what they're really going to be paying, we need this idea of the annual effective rate. So let's look at a quick example. If I invest $100 for 1 year at 6% compounded monthly, what's it going to grow to? Well, if I put it in there using my FE formula, I actually end up with $106.17. Where did the 17 cents come from? That's the extra boost I get, even after just 1 year, at the very beginning, from the compounding. So I get a little bit more than 6%. And in fact, if you look at it, you can see, don't I end up with 6.17%? So that's really the same as if we'd invested at an annual rate of 6.17%, but only compounded once, not compounded until the end. And here's the formula for it. 100 times 1.0617 to the power of 1, just compounded one time, will give me the same answer, won't it? So we've really made 6.17% interest on our money, or $6.17 is the actual amount we would get, or that we would pay if we were paying out. So that's a pretty important notion. We need a formula to help us figure this out, and here it is. We use a kind of a fancy letter F to represent the annual effective rate. You may also just see the abbreviation AER for annual effective rate, one or the other. And here's the notion. We'll start with kind of something that looks like our future value formula here, but instead of N, I'm going to use M, because I'm interested in 1 year's worth, or the annual effective rate, and M is how many times we compound in a year. So I'll switch that in there for N. I'm going to then subtract 1 at the very end, and that'll kind of take out this 1 after the compounding effect to leave me with sort of my new rate, essentially. And so that's the formula that we need for the annual effective rate. Let's go ahead and try it out. A car dealer advertises a financing rate of 4.99% compounded monthly, and a lot of people might read that big ad in the newspaper and go, okay, just under 5%, that's not too bad. But we know that the monthly compounding is going to have an impact, isn't it? It's going to charge us a little bit more interest. So what is really the annual effective rate that we're going to pay if we borrow money from this dealer to buy the car? Well, we're given a J12 is equal to 4.99%. It's compounded 12 times a year, isn't it? That's a J12. And little I in this case, I'll divide that 4.99 by 12, and I get a small number, 0.004158333, and those kind of repeat, actually. It's best to work with the memory keys in your calculator. So once you work that out, you could store that if you wanted, or just keep going with your calculations for the annual effective rate. And the first thing you're going to do is add 1 to that to end up with this right here. Once you've got that, We're going to raise that to the power of 12, then subtract 1, and we end up with 5.11%. The annual effective rate that we're really paying is actually over 5% on this loan. So if you went and bought a car from this dealer, you wouldn't be paying 5 or just under, you'd be paying over 5%. Let's give you a chance to try one out. You got a Visa card that charges a rate of 18% compounded monthly on the unpaid balance. That's pretty typical for a lot of credit cards out there, something like that. Now that's compounded monthly, so that compounding effect is actually going to make us pay more, isn't it, by the end of the year? What will we really pay if we leave a balance hanging around on our credit card? Well, go ahead and work out the annual effective rate for this one. I'd suggest you hit pause right now. Should just take you a few minutes. And then when you're ready, come on back and I'll run through it with you so you can check your answer. Well, let's have a look. We were given this rate of J12 is equal to 18%, and M is equal to 12 in this case, and I is equal to 0.015. What's the annual effective rate? 1.015 to the power of 12 minus 1. And that works out to 19.56%. So you're paying much closer to 20% on this credit card if you keep a balance going. You can see maybe that's why they warn people not to do that with their credit cards. And believe it or not, department store credit cards tend to charge a little bit more. Maybe a J12 equals 24%. So again, that's going to work out even higher than that. So that's a really bad trap for people to get into. A good personal tip for you or for the people you care about: avoid racking up debt on your credit cards. That's really as easy as it is, isn't it? But that's a great little thing to be able to do, because we can now take different types of investments where maybe they quote, nominal rates that are compounded differently, and convert them all back to an annual effective rate to not only compare them, but to see what we're really going to get. We can also do this on our calculators with a built-in function on your calculator rather than using the formula, although you got to admit this formula is pretty quick and easy. But let's go ahead and look at the calculator now. Now we can also use our calculator to help us out rather than using the formulas if you wish. There's a button on there called the iConvert button that we can use. So let's have a look at how that works. I want to calculate the annual effective rate for J12 equals 4.99%. That's what we had a little bit earlier. Well, I want to use second iConvert. Now, if you look at the calculator, we have to press the second key and then the iConvert, which is behind the number 2. Once you've got that, you'll come up with a screen and it'll say NOM on there, and we can enter the nominal rate. Now, the nominal rate is the one that we're given that we want to convert from. So in this case, the 4.99%. So we'll type in 4.99 and press enter. And it'll say NOM equals 4.99. Then you want to arrow down. So use the arrows in the top row, arrow down, not just once, but twice, until you get to CY, and that stands for how many compounding periods per year. Well, we've got 12, don't we? Because it was a J12 is equal to 4.99. So that's where I'll put the 12. And now the calculator knows that I'm starting with J12 equals 4.99 as my nominal rate. Once I've got that far, I'm going to arrow back up one to effective rate, EFF. And I want to compute that now. So I press the compute button, and I get 5.105, etc., or 5.11% if we go to 2 decimals. So I end up with 5.11%, the same as what we got earlier. And that's an easy way to do it. Now we can also enter any two of these 3 items. So if I wanted to start with an annual effective rate and then convert it to a nominal rate, I could do that. I could enter the effective, EFF, and enter the compounding frequency, and then go back up to nominal and press compute. And that would work as well. And we're going to use that feature in our next lesson as well, when we convert from one rate to another rate. But for now, we know how to get the annual effective rate, and that's great. I hope this is clear, and practice a little bit with these to make sure you're comfortable with them, either with the formula or with the calculator. It doesn't matter too much. You just want to make sure that you're able to do them consistently and get the right answer. Bye for now.